So I'm going to stop sharing for a second because I forgot one thing here. Give me 1 minute, class. Okay, here we go. I forgot to open up my screen mirroring app on my computer, and it just took me a second there to open it up and get things connected. You know how it goes. Okay, so you see on the screen there, our topic for tonight is solving trig equations. So solving trig equations is very similar to solving regular equations with one difference. And of course, the difference is finding the correct angle or angles that satisfy the equation. All right, so you have to find the angle or angles, and a lot of trig equations normally have at least 2 or more solutions. Some might have no solutions, some might have one solution, but trig equations oftentimes can have multiple solutions. So we are interested in finding the angles that satisfy the equation. So remember, to satisfy an equation just means when you find your answer and you go back and you plug in the value that you found, your equation should balance, right? You should get 2 equal numbers in your equation. So for example, let's look at satisfying a regular algebra equation. So this first example here isn't trig. It's just regular algebraic equations. So is x equals 2 a solution of, let's say 3x minus 7 equals, let's say 0. All right, so the equation, you don't really have to solve the equation because I'm asking you to check to see if x equals 2 is the answer or not. So what do you do after you solve a problem? You go back to the beginning, you plug in your number and see if it works. So we will do 3 times 2 minus 7. We want to know, does that equal 0? Well, I get 6 minus 7. Let's put a question mark over the equal sign. 6 minus 7, of course, does not equal 0 because that's -1. That's equal to 0. So therefore, x equals 2 is not a solution. All right, because when you get to the last step of the substitution there, we get 2 different numbers. We get -1 on the left side and 0 on the right side, which means the equation is not satisfied with that solution. Okay, so now with a trig equation, you would do the same exact thing. So we want to know, all right, is theta, which equals, let's say, pi over 4, a solution of the equation 2 sine of theta minus 1 equals 0. And then we're also going to check the same thing for theta equals pi over 6. So we're going to do two different checks here. All right, so let's start with the first solution for theta equals pi over 4. Just do what we did with the algebra equation. Just plug it into the equation for theta. So we would have 2 sine of pi over 4, where theta is, minus 1. Does it equal 0? So now find the value of the sine of pi over 4. Now you have to do that. So remember what you can do is, I'll come back to that screen in a minute, use your unit circle. All right? So we want the sine of pi over 4. We want the exact value for that. So here's pi over 4, 45 degrees. And don't forget that the first number in the pair there is cosine. So your x is your cosine, but we don't want that. We want sine. The sine of pi over 4 is the square root of 2 over 2. So now we're going to take that number and we're going to substitute it in. All right, so it's 2 times the sine value of radical 2 over 2 minus 1. Is that going to equal 0? Well, let's see here. The 2's cancel, right? 2 over 2. And that gives me the square root of 2 minus 1. That's not 0. If that were 1 minus 1, sure. But the square root of 2 isn't 1. So therefore, theta equals pi over 4 is not a solution. What about the second angle? Pi over 6. So repeat the same process. Plug it in. So we do 2 times the sine of pi over 6. So we're going to go to the unit circle and grab that. Does that equal 0 after I reduce it down? So let me give you a minute there just to get caught up a little bit. And if you are caught up, can you find the sine of pi over 6? Find the value. What is the sine of pi over 6? It should be 1/2. And then bring down the minus 1, the question mark and the equal sign. Is that going to equal 0? So of course, the 2's cancel out again. We get 1 minus 1. That equals 0. Absolutely. So we can say with certainty here that theta equals pi over 6 is a solution. Okay, because you can see there the left side and the right side, they're both 0. And that's what it means to satisfy the equation, is that the equation is balanced with whatever number or numbers you plug in. Because remember, an equation is a statement that two things are equal. And if they end up not being equal, your equation isn't satisfied. Okay, so now this is kind of like a way of checking your solutions to see if they're correct or not, which, most of the time we really don't do that. So now the question is, okay, well, how do you come up with solutions to trig equations? So this example here, I gave you solutions or possible potential solutions that we had to check. So how do you actually find the thetas? How do you find those angles? So that's what we're really going to be focusing on tonight. And you will need the unit circle chart for a good part of this. So make sure you have your unit circle chart handy, just in case I don't always show mine. Okay, so before we actually start solving equations, we have to review one thing. from yesterday. And it was pretty much the very last thing that we wrote down was about the trig functions and their periods. Okay, so remember the trig function and its period. So remember we had sine, cosine, cosecant, and secant all had periods of 2 pi. And our period just means the length of the x-axis. So it's like a horizontal length. If you want to think of it in terms of time, we could always think of it like that too. You could say it's the length of time or the horizontal length that it takes for the function to repeat itself. So remember, trig functions are periodic functions. That means they're going to cycle over and over and over. They're going to do the same thing over and over. They repeat themselves. So that means, the sine function at now will equal the sine function at a later point. And then it will equal another later point because it just keeps repeating itself. Okay? So the period there is 2 pi. So what that can mean in terms of angles is that any angle that we find that corresponds to those 4 functions can also equal, so think of that as now, theta now. If we want a theta later, it will be theta plus k times the period. Okay? And then the other 2 functions of tangent and cotangent, they have a lesser period of pi. So a theta now for tangent or cotangent will equal to theta plus k times pi, not 2 pi, right? Because the period is 1 pi, so there's no 2 here. And this would be a later equal value. So if you remember a few minutes ago, I said how trig equations can have multiple solutions. That's because of this. Because one solution now can equal another solution later and another one much later just by adding on the period multiple times. All right, so that can mean you can have an infinite number of solutions. You can have an infinite number of solutions. All right, so let's write down this. So to kind of generalize what I'm saying here, number 1, trig functions typically have an infinite number of solutions. And you can see that in their graphs. So like, for example, if we take the sine function, and remember that if you graph a function, you can find its solutions on the x-axis. The x-intercepts would be the solutions. So if we were to graph sine, remember how sine looks? Remember, it starts at the origin and then it just does this wavy thing. Cosine does the same thing. And of course, you can go back the other way. This is a very sloppy graph, but this is y equals sine of x. And of course, this would keep going and going to negative infinity and positive infinity. So again, the solutions to the equation can be found on the x-axis. Do you see that there's a lot of x-intercepts here? All right, there's an intercept here and here and here and here and here and here and here. There's so many intercepts. All right, and then that would be infinite. All right, so the x-intercepts give us the solutions. And because of the behavior of this type of function, the way it repeats itself over and over like this, it's going to hit the x-axis an infinite number of times. So then how do you write an infinite solution? So that's the next question. How do we write an infinite solution. And we do that by using what's called a general formula. And we just wrote down the general formulas right up here next to the table, all right, with the k values, okay? So we use, all right, these are expressions that include period and a whole number k. All right, and again, they are, so for sine, cosine, cosecant, and secant, the general form, the general solution, I'd rather call it a general solution than formula. So let's edit that right there. So we're going to call this the general solution. Formula sounds like something you have to use and plug numbers in, and you're kind of doing that, but general solution is a better way of describing these. So for these, we use whatever angle we find plus k times 2 pi. For tangent or cotangent, because they have period pi, it's plus k times pi. All right, and we use these for each unique theta. All right, so let's do an example. How would this actually look with numbers? All right, so let's suppose that the general solution to a trig equation is pi over 5 plus 2 pi k, or k times 2 pi rather. You know what? I'm going to change that. The pi over 5, that's on the lab. You'll be doing that on the lab. Let's make it pi over 3. I think you can handle a 5 on the lab. Okay, so we're going to do a couple things here with this. All right, so the first thing we're going to do is a very similar question to your lab. So we're going to find one positive and one negative solution for theta. So in other words, I want two different answers, right? I want one that's positive and one that's negative, knowing that the general form of a solution to the equation is given by pi over 3 plus k times 2 pi. So this depends on what you choose for k. So you're going to choose, whatever you want, 2 values for k. And you want to choose them so that your answer, one of them is positive and one of them is negative. And you can absolutely use k equals 0 if you like, Because remember, k is a whole number. All right, so let's start with our first value of k equals 0. That's always a nice number to start with because you don't have to worry about the second part. So you would get theta equals pi over 3 plus 0 times 2 pi is pi over 3. And since that's positive, there's my positive answer. Remember, 0 times 2 pi is 0, gone, right? All right, so I just found a positive value. So now, how do you think we could find a negative value there? Because remember, it's pi over 3 plus. So in order to make this negative, I need to subtract something. So how about I let k equal -1? Let's do that. Let's see what happens. So now theta would be pi over 3 plus -1 times 2 pi. Now that's going to end up subtracting 2 pi, which is probably going to make this thing negative. So pi over 3 minus 2 pi is what we have to figure out. Now, here you're going to have to use a little bit of fraction math. So put 2 pi over 1. And now let's get a common denominator. So this will be pi over 3 minus 6 pi over 3. So how did I get 6 pi over 3? Now, pay attention to the denominator of 1. In order to make that a 3, I can just multiply it by 3. But remember, when you do something new to an expression, you have to balance it. So that means I have to multiply the numerator by 3 also. Okay? So if I multiply the denominator by 3, I got to multiply the top by 3. So 2 times 3 gives me the 6. 1 times 3 gives me the 3. And now, these two fractions are set up with the same denominator. Now you can subtract or add them. So here we're going to subtract. So now how are we going to subtract these? Well, think of this first one as a 1 pi over 3 minus a 6 pi over 3. Well, it's still going to be over 3. So I'm subtracting the numerator, right? 1 pi minus 6 pi is -5 pi. All right, just think 1 minus 6, and then the pi symbol carries over. Now we have a negative answer. So there's a negative angle. That would be a negative solution. Okay, B. Find 2 other positive values. So that means you're going to have to select other values of k. You can't reuse 0 or -1. Now, of course, I think negative k values will give us negative angles. So I think for this part, it's probably best not to use any negative k values because we'll end up with negative answers. So how about we use k equals 1, right? That seems like the next best bet. And then sure, I could use k equals 2, I could use 20, I could use any positive k value that I want as long as it's a whole number, right? Whole number k values. So don't use decimals. Don't use 2.5. Okay, so now let's plug them into our general form where theta again is, remember it's pi over 3. So remember it's pi over 3 plus k2 pi. So plus 1 times 2 pi. So that's pi over 3 plus 2 pi. So just like before, let's put that over 1, get a common denominator of 3. So that means this would become 1 times 3 is 3, 2 times 3 is 6. So notice what you're doing here is the opposite of reducing. You're doing the opposite of reducing, whatever that's called. Okay. So then what does that equal? It's something over 3. Remember, it's just 3 for the common denominator. You have 1 pi plus 6 pi is 7 pi over 3. And it's a positive number, so I have a positive answer. All right, next, we have pi over 3 plus 2 times 2 pi. All right, k times 2 pi would be 2 times 2 pi. Will be pi over 3 plus 4 pi. So again, it's the same idea when we were graphing angles last week. Remember how we took an angle and then we rotated it once or 2 times around and it made like a big spiral on the graph? This is exactly what's happening with these solutions. I have pi over 3, which is like 60 degrees, and then 4 pi is 2 pi twice. So it really just means that when I'm at 60 degrees, I'm going to rotate that angle 2 more times all the way around. And it just ends up back in the same place. So it's 2 full rotations. That's the idea. All right, now let's get a common denominator. So put 4 pi over 1, move that mouse. So what do I do to make this a 3? I multiply 1 by 3 and I get 3. 4 times 3 is 12. So 12 pi over 3 will help me add these together. So again, 1 pi plus 12 pi is 13 pi over 3. Okay, so this is how I would like you to do problems like these. All right, certainly in radians, keeping it in fraction form, using common denominators, no decimals in the calculator, okay? I know it's a little tedious to do this, but you do need to be able to do this for calculus. Okay, remember the name of the class is Precalculus. We are training ourselves for calculus. So you got to force yourself to do some of this old arithmetic. Because if you don't, calculus will be a little tougher if you don't have some of these basic skills down. Okay. So that's how we work with general solutions. So once you find the general solution, then it's easy to find other solutions just by adding 2 pi k with different k values. So remember, the whole idea is that you choose the k values, and typically you start with 0 because it's always a nice starting value. All right, example number 2. All right, so determine if theta is between 0 and 2 pi. Now, typically, with a lot of trig equations, we don't necessarily have to write down multiple solutions. In certain situations, the directions might just ask you for answers that are between 0 and 2 pi. Because remember, 2 pi is 360 degrees. It's the full unit circle. So a lot of times, the problems may just ask you for angles on the unit circle. So you have to know whether or not your answer is between 0 and 2 pi or not. Because sometimes it's hard to tell because, well, fractions, right? Fractions kind of suck. So you have to, look at it and figure out, is this between 0 and 2 pi? I'm not sure. So let's take a look at a couple of ways where we can determine that. So number 1, I have theta equals 3 pi over 4. Okay. So now, the trick to figuring out if this number is between 0 and 2 pi is just ignore the pi symbol altogether. All right. So the trick here is ignore pi. All right. So then what you would be asking yourself is 3/4. So notice I just dropped the pi out of there. It's like a mental drop. All right. We're not really dropping it. We're ignoring it. Is 3/4 between 0 and 2. So notice I also dropped the pi out of the 2 pi. You don't really need pi to think about these numbers, okay? So the trick here is just to look at the numbers without the pi symbol and just ask, is this number between 0 and 2? And of course it is, because 3/4 is 0.75. So yeah, it's between 0 and 2. So here we would say yes. All right, what about 7 pi over 4? So again, the trick here is, don't worry about the pi symbol. You don't need that to really determine this information. So what we're going to do is we're going to ask ourselves, is 7/4 between 0 and 2? Now, 7/4, just, use your calculator, divide them. What's 7 divided by 4? It's 1.75. And that's between 0 and 2. So yes, 7 pi over 4, therefore, is between 0 and 2 pi. Okay? So it all depends on the fraction that you see there, not the pi symbol. All right, one more. How about a theta of 11 pi over 2? So again, all you need to think is this question. Is that 11 over 2 that I see there, ignoring the pi symbol, between 0 and 2? Also ignoring the pi symbol with the 2 pi. All right, so just think 0 and 2. Well, again, what's 11 divided by 2? Use your handy calculator to do that. So 11 divided by 2 is 5.5. Well, let's see, 5.5, is that between 0 and 2? No. So therefore, this angle here is not between 0 and 2 pi. Okay? So that's the trick with those. Now, why do we need to go over this? Well, when you solve equations like up here, okay, when you have a problem that says include only the answers that are between 0 and 2 pi, like some of these that are circled here on the screen, we would scratch those off because some of these are more than 2 pi. And of course, the negative one, that would not be included because 0 and 2 pi is a positive range. So like you would scratch off the negative. What's 7 pi over 3? That's 2.3. So you would scratch this off. 13 pi over 3, that's 4 point something, right? 13 over 3. So you would scratch that off also. So 3 of these numbers that you see on the screen here, they're not between 0 and 2 pi. Only the top one is, right? Because it's 1/3 pi. So just think 1/3. That's between 0 and 2. Okay? Okay, now let's solve some equations. So solving basic trig equations. That will be the first part of our lecture. And here, this is where you need the unit circle. So make sure you have that on hand. All right, so the first thing we're going to do is we're going to write the general solution, or solutions, I should say, for each equation. So that means the general solution, that's when you're using those terms with the k's and the pi's and the 2 pi's, okay? So that's the idea. So example number 1. Solve for theta for the cosine of theta equaling 1/2. So at what angle is the cosine equal to 1/2? Well, again, remember on the unit circle, cosine equals x on the unit circle. So you want to find where x equals a half on the unit circle. And there's two of them. There's two. So let me give you a minute there to catch up, and then I'm going to switch to my unit circle, and I will point them out for you in case you're a little lost. All right, let's switch. Here we go. All right. So where is the x value a half? So remember, cosine is what we're looking for. So it's the x values where they are positive 1/2, just positive 1/2. So I see one right here, but we want the angle. So theta would be pi over 3. Now, could you write 60 degrees down? Yes, you could, but we're going to use radians for these, okay? Radians. And I'm sorry, I know some of you don't like radians, but again, the reason is for calculus, all right? If we don't force ourselves to learn radians, again, it will be an issue when you get to calculus because you won't remember it, you won't have enough practice with it, so it's important that we make sure we stick to radians. All right, and there's one more. Just go around the circle till you find that x value of positive 1/2. And the angle there is at 5 pi over 3. And that's it. If you go around the circle, no other x value is positive 1/2. There's negative 1/2, but we don't want that. All right, so let's take those back. So therefore, once you find those numbers, you're pretty much done. So therefore, the general solutions, there's two of them because we just found two angles, right? And it's a cosine function, right? So, and also remember that cosine has period 2 pi. So you have to remember this. So the first solution is pi over 3 plus k times 2 pi. So notice I brought the angle pi over 3 over, and I added on that k term. And it has to have the 2 pi there because, again, it's a cosine function, so k has to be multiplied by its period of 2 pi. And then the other angle we found was 5 pi over 3. And just tack on k times 2 pi. And that's the general solution. So when it says find the general solution, that's all you have to write. All right, you don't have to plug in values of k unless the problem tells you to find 4 solutions or find 10 solutions. Then you got to plug in k values. If the problem says find angles between 0 and 2 pi, then really the numbers that you find initially are it. Okay? So that's the idea there. So the unit circle will help you find the solutions, especially if you don't have these memorized or if you don't have another type of graphic that finds the values for you. Use the unit circle. Okay? All right, let's do another one. Number 2. All right, solve for theta for the sine of theta equals 1. So what do we need to remember here? On the unit circle, don't forget that sine are the y values. So we're looking for where the y values are 1, because that will give us the sine. All right, so let's switch. I'll come back. Let me get rid of this. Okay, so the y value will give us sine, and we want to see where it's equal to 1. Now, one little hint here, whenever you see ones or zeros, look at the top, bottom, left, and right of the circle. So I mean the top, the left, the bottom, and the right. That's where you're going to find ones and zeros. Now, specifically, where is the y value 1? Right here at the top, right? The second coordinate there, see it's 0, 1. Okay, so we would use that angle, which is 90 degrees or pi over 2 radians. And that's it. This is only one solution for this. Like this one down here, we wouldn't use that even though there's a 1 there. That's an x value, right? We want a y value that's 1. All right, so let's go back and write out our solution. So therefore, the general solution would be theta equals pi over 2 plus k times 2 pi. All right, and that's, again, you have to remember that sine has period 2 pi. So that's why we're adding k times 2 pi. All right, let's do 2 that involve tangent, because tangent you have to think a little harder about. So tangent of theta equals 1. So how do we get tangent on the unit circle? Well, remember tangent is sine over cosine, or the y values divided by the x values. So if y divided by x equals 1, right, or sine divided by cosine equals 1, right, and I'm getting 1 from the equation, right, because tangent has to equal that. Well, what does that tell us about x and y? They must be equal. They must be equal. So now what you're going to do is on the unit circle, you're going to find points, x and y, such that they're equal, identical. All right, so let me bring up my unit circle. Take a look at it. And without me for a minute, see if you can find the 2 pairs that are identical. 2 pairs that are identical. They both have to be positive or they both have to be negative. If you can see this. I know the numbers are a little small. All right, so the one of them is right here. Radical 2 over 2, comma, radical 2 over 2. Identical x and y values. All right, x and y are equal there at radical 2 over 2 at the angle pi over 4. Can you find the other one? If you don't see it yet, I'll give you a hint. It's down here. Hopefully you see it now. It's a little bigger. Here's another pair with identical x and y values. Because when I divide them, I'm going to get 1. All right, now will be the tangent. So therefore, my angle is 5 pi over 4. So my other angle is 5 pi over 4. So again, we're looking for the tangent, which is found by dividing y and x. So if I divide these, I'll get exactly 1. They're not the nicest numbers, but I mean, if you divide 2 numbers that are the same, it's 1. All right, so coming back to the screen here, our solutions are pi over 4 and 5 pi over 4 plus what? K times, fill in the rest. All right, so you have to remember that tangent has period of pi. So it's k times pi, no 2 pi. Okay, let's do another tangent problem where the tangent of theta equals the square root of 3 over 3. So we have to use the same idea on the unit circle that tangent is y divided by x, sine divided by cosine. So I have to find the pairs such that y over x is the square root of 3 over 3. So I'm going to give you a hint as to what we're going to need. Right? Obviously, we need a square root of 3. So you want to look at the points that have square roots of 3 in them. Right? So you would ignore square roots of 2. That's not going to help you in this problem. So find the ones that have square roots of 3 in them. So if we look at quadrant 1, there are points with these two numbers, and then switch the other way. One of these would actually help us find the solution. The other would not. So what we want to do is, let's divide them to see which one gives me the square root of 3 over 3. All right? So if I do y over x, I would have the square root of 3 over 2 divided by a half. Now those 2's would cancel. And then you see how it's arranged? It's the square root of 3 over 1, which is the square root of 3. Now, that's not it. It's close, but no cigar. So let's try dividing them the other way, where the 1/2 is on top, and the square root of 3 over 2 is in the denominator. So the 2's cancel out, and I get 1 over the square root of 3. And then when I rationalize that, I get what I want, square root of 3 over 3. So that would be a yes. So that means we're going to scratch this one off. So now what we want to find are the 2 points and the 2 angles, of course, that match up with coordinates where you have the square root of 3 over 2 first and 1/2 second. Now, can you think of another point that will also give me positive radical 3 over 3? How about this? Would this work? Would that give me the same answer? Yes, because negative divided by negative would also give me positive. So when I'm looking for points in the unit circle, I do have to do a little bit of mental math to kind of like figure out if it's the right set of coordinates or not. So this will equal that value also. So now let's find these 2 points in the circle, and we'll find our angles. All right, so that first one is at pi over 6. And then the second one is down here at 210 degrees. All right, the 2 negatives, if I divide them, it'll be positive. Remember, it needs to be positive radical 3 over 3. So 7 pi over 6. Okay, so let me go back to my notes. So it's what, pi over 6 and the 7 pi over 6. And then don't forget, for the general solution, we have to add k times pi because it's tangent, and k times pi. So these would be my general solutions for that problem there. So sine and cosine are easy just because the x value is cosine and the y value is sine. You don't have to worry about dividing them when it says sine or cosine. But when it says tangent, you got to divide them. You have to find the one that matches the value in the equation. Okay? Okay, so now let's do our first group work. Group work number 1. We'll be doing problems 1 to 3. And let's see here. They shouldn't take too much time. I'm thinking it might take you 15 minutes maybe to do these. So why don't we make this our 30-minute break? Because when we come back, we're going to solve more equations a little more in depth. So we'll want to spend a little more lecture time doing that. And that's going to be the end of the lecture. So if things go smoothly, we actually might be done by 8:30 tonight, because this is all we're doing tonight. Because we're pretty much at the end of trigonometry, which is great. I'm sure you're probably very happy to hear that. But actually, yeah, today's the last full day of trigonometry. Next week will be our last week. We'll be learning about vectors, and we'll also be learning about parametric equations. There is a tiny little bit of trig in there, but it's like a sine or a cosine here and there. That's it. It's nothing intense at all. So that would be our plan for next week. But this is it for trig. Everything that you learned in these last 2 weeks is all you really need to know for calculus. Okay, so enough of me talking. Let me unshare. And there's a question in the chat here about solving these questions, about using the reference angle. So for those of you that have learned about reference angles, absolutely, you can do that. It's probably a little bit, faster, if you know it mentally. Yeah, it's another method that you can use. So yeah, when you're finding angles, so actually before I actually put you in into your groups, there are other ways of doing what we're doing in the unit circle. So the unit circle is not the only way you can get these solutions. There's, let me share my screen one more time. All right, so other ways of finding the angle. So we use the unit circle because it has a lot of common values that will come up a lot. So it's like a table, but it's a round table, right? So the unit circle is one way. This is what we're learning because this is an at-home course. So the other methods are more of like a memorization method. And, I think it's going to, for me at least as a teacher, forcing you to memorize something that I really can't force you to memorize. Because when you're taking your labs and your tests, there's no point in trying to memorize things if you can use your books and papers at home. All right. So another method is actually a method called using a reference angle. This is more of like a memorization technique. So maybe on your own there, not tonight, of course, but if you're interested in learning about, different ways we can memorize how to come up with these angles, I would check that out. All right, so definitely do a good Google search or YouTube. There are lots of different ways that, that people will actually memorize these trig values. And when you think about the diagram, so when you think about the diagram there of the unit circle, this shouldn't be hard to memorize. Because remember, I pointed out the patterns in the numerators and the denominators of the radian angles. All right, that's something that you can memorize to remember where the angles are located. But also take a look at all the numbers in the x and y coordinates. There's a lot of repeated values. There's lots of 1/2. There's lots of square roots of 3/2. There's lots of radical 2/2. So there's lots of repeats, which makes this easy to memorize. The negative signs are just based on the quadrants that you're in. So like notice in quadrant 1, everything's positive. In quadrant 2, the x value is always negative. In quadrant 3, both x and y are negative always. And quadrant 4, the y value is always negative. Now, also, I'm going to point out one more thing here before we actually get to this group work and break. There's 4 letters associated with these quadrants, A, S, T, and C, and it's some people remember it as all students take calculus. A, S, T, C. All students take calculus. There it is. It wasn't on the screen. Sorry. Okay, and A lines up with the first quadrant where everything's positive. So all actually corresponds to everything, right? Every trig value, every trig function is positive. S, T, and C actually stand for sine, tangent, and cosine. So like in quadrant 2, the S is in quadrant 2, and that corresponds to sine. What does that exactly mean? It means that the sine is positive. And then in quadrant 3, there's the T there. That tells you that in quadrant 3, any value of tangent in quadrant 3 will be positive. And in quadrant 4, the C there for cosine means that any cosine value, if you're in quadrant 4, will be positive. Okay? And so see there's 3 functions there, sine, tangent, and cosine, where one of them is positive, the other 2 are negative. Okay? So like in quadrant 2, the sine is positive, but the other 2 are negative, tangent and cosine. Okay? So again, just different ways of looking at all the different patterns of these angles. All right, so one more thing here with reference angles. So a reference angle is an angle between 0 and 90. And I'm going to point out just one type of reference angle. So let's take a look at a 30-degree angle. So like this angle here makes a 30-degree angle with the x-axis. Look at its coordinates. You got radical 3 over 2 and 1/2. If you go to the second quadrant, this angle here, notice how it's symmetric to the 30-degree angle, but also this angle here between 150 and 180 also makes a 30-degree angle with the x-axis. Take a look at the coordinates. It's the same 2 numbers, same order, except the first one's negative because you're in quadrant 2. If you take a look at this angle here between 180 and 210, this also makes a 30-degree angle with the x-axis. Take a look at the coordinates. They're in the same order, radical 3 over 2 first, but they're both negative. And then in this quadrant, between 360 and 330 is another 30-degree reference angle. And take a look at the coordinates. All 4 of these coordinates have that square root of 3 over 2 first, and the 1/2 is second. All right, and the same will apply to all the 45-degree angles and all the 60-degree angles as well. So this is one way of memorizing the values. All right, and one more thing I want to share with you. Let me go back to my notes. Where the heck are they? Let's see. Oh, here they are. All right, and a third way, which kind of goes with reference angle also, is this little graphic that looks like this. And maybe some of you have seen it. So that's a square root, all right? And of course you have an S and a C, which stand for sine and cosine. And then on top are the angles, 0, pi over 6, pi over 4, pi over 3, and pi over 2. This is a quick little handy way of remembering sine and cosine of certain angles. And then all this also gets divided by 2. All right, now, inside the square root, looks like there's 10 numbers. It's either 0, 1, 2, 3, or 4. You're going to pick one number. Like, so for instance, let's say I pick this number here, this 3. Notice it's in the first row there, right? So this is the sine row and this is the cosine row. What this represents is the sine of pi over 3 is the square root of 3 over 2. So you notice the 3 is inside the square root, so it's a square root of 3, and then everything gets divided by 2. And the angle lines up with the circled number, okay? So that would be the sine of the angle pi over 3 is the square root of 3 over 2. All right, one more, and I swear we'll do a break. What about this? So think about what that would mean. That would be the cosine, because it's in the cosine row, at angle 0 is the square root of 4 over 2. Now, if you simplify that, you get 2 over 2 is 1. So some of these will actually simplify. So if you go to your calculator, you type in the cosine of 0, it's going to be 1. So this is a quick little graphic that can be used, which is also in association with reference angles. So you can Google and YouTube both of these things. So if I were you, I would think about doing that, looking at the different methods of memorizing these angles and trig values, especially for calculus, because I can guarantee you, you probably won't have me for calculus because I don't have enough seniority yet to teach some of the higher level classes. So you're probably going to get, a teacher that's been there for a lot longer, and of course, I don't judge, but they're older and they're tougher. So they're probably going to expect you to have some of this memorized. So if I were you, I would take some time to research the memorization techniques of these trig values. So Fady, I hope you really liked that really long answer to your question. So that was a very good question because it's something that I think everyone should be aware of. So great question. All right, so I'm glad we're making this a 30-minute break because now you're really going to need a break. So let me pause the recording. Also, as a quick sound check, just let me know if you can hear me in the chat just by typing yes. Great, great. Thank you so much. Thank you. All right, then here we go. Let's see if I can find my screen. Oh, I got to share it. That's why. Okay, so let's now continue with this example. All right, solve the equation 2 times sine of theta plus radical 3 equals 0 on the interval from 0 to 2 pi. Now take a look at that inequality. We have 0 is less than or equal to theta is less than 2 pi. So if we were to put that in interval notation, that would be a bracket at 0 and parentheses at 2 pi. Now what that means is, it means include 0 if it's an answer, but not 2 pi. Why is that? So we include 0, but not 2 pi. And the reason for that, if you look at your unit circle, or if you remember your angle measurements, 0 and 2 pi are in the same position. So therefore, 0 and 2 pi would be considered equal. So you wouldn't write them down separately because that means you're counting the same answer twice. So again, when you think about graphing an angle, all right, so remember 0 degrees is here. And then when you rotate all the way around, 360 is also there, so they're equal. And in radians, that's 0 and 2 pi. So we don't write both of those down as an answer. So according to this problem, if they are an answer, you write down 0 not 2 pi, because otherwise you'd be writing the same thing down twice, and we don't want to count it twice. That's all that means. But also, here the problem also wants us to find angles only between 0 and 2 pi in this problem here. All right, so first, let's take the first step of this equation by moving over the square root of 3 to the other side. So I would have to subtract that. So I get 0 minus the square root of 3 is the square root of 3. All right, next step, I would divide both sides by 2. So I get negative radical 3 over 2. All right, so sine of theta, remember, has period of 2 pi. So what we could do because of that, we could look in the unit circle. For what? For where the sine, which is, remember, y, is equal to that number, negative radical 3 over 2. And the reason why we can use the unit circle especially here is because of this interval here. The unit circle is on the interval from 0 to 2 pi. So any angle in that circle would satisfy this given restraint here, or constraint. It's a constraint. Okay, so let's look at our unit circle and find where the y values are negative radical 3 over 2. Okay, so I'll find one of them for you. All right, it's actually down here. So you have a negative radical 3 over 2 for the y value. So therefore, 4 pi over 3 is one of the solutions. And the other one is very close to it. It's also over here. All right, I know that my y value is negative, so it has to be in the bottom half of this diagram. Also keep that in mind. The y value is negative. It has to be in the lower half of the circle. And what angle is that? 5 pi over 3. So 4 pi over 3 and 5 pi over 3 would be your solutions. Now you might be wondering, how come I didn't add on k times 2 pi? Because here, when we say we want an answer that's between 0 and 2 pi, it's looking for specific solutions. Remember that the general solution, so let's compare the answers. So this is what we call a specific solution, because they're between 0 and 2 pi. The general solution, you would take those angles, 4 pi over 3, and you would add k times 2 pi, and 5 pi over 3, and add k times 2 pi. Why aren't we doing that here? Because remember, the general solution represents the infinite solution. And I don't want that here. I want specific solutions that are only between 0 and 2 pi. So since I know that my solutions can only be between these two values, that means your solution can't be infinite. All right? So in other words, the specific solution is the opposite of infinite. It's a finite solution. So there's the difference between what we did before break and what I did in this problem here by circling 4 pi over 3 and 5 pi over 3. I only want finite solutions because I specified an interval where those solutions have to exist. Whereas again, the general solution represents all the many different possibilities that those angles could take on. All right, so in this case, this is what we want here, are just those two circle values. All right, so this is not needed here. Okay? Okay, let's try another one that's just like this, very similar. All right, so number 2 here. I guess this was number 1. Let's number them so we can be organized. This is a college after all, so we should at least try to be a little organized. It's always helpful. All right, so number 2 here. So let's say we have 2 times the cosine squared of, let's use x this time, or theta, it really doesn't matter, minus 1 equals 0. All right, so the very first step there, we do want to isolate the cosine term. So to isolate the cosine term, we add 1 to the other side first. So we get 2 cosine squared of x equals 1. And I didn't write it down, but we're also solving this on, again, 0 to 2 pi. So I want a finite solution for this problem. All right, next, there's that 2 in front. Divide that. So we get cosine squared of x equals 1/2. Now you want to be careful here because we're not going to be looking up 1/2 on the unit circle because I'm still not done. I have a square on the left side. So now I'm going to take the square root of both sides. And then that will eliminate the cosine squared and just, oh, no square. All right, and it brings down the cosine of x. Remember, a square root will cancel out squaring. And then the square root of 1/2 is plus or minus. The square root of 1 is 1. The square root of 2 is square root of 2. Rationalize, that's plus or minus square root of 2 over 2. So now what we can do is on the unit circle, so you want to find all cosines, or in this case, remember cosines are the x coordinates that equal plus and minus radical 2 over 2. And that's to get the angles. So there are, I'll tell you here, there are 4 solutions. All right, for the angle. And note here that my angle is x, right? So be careful with that. That's really theta. So x is really theta here. All right, so can you see where the x values are square root of 2 over 2? So like in the first quadrant, right there at pi over 4. Here's an x value. That's square root of 2 over 2. So pi over 4 is 1. Whoops. If I go over here, here's a minus square root of 2 over 2 for x. Remember, I want plus and minus square root of 2 over 2 for the x coordinates. So 3 pi over 4 is another angle. If I drop down, so notice here and here are square roots of 2 over 2 and minus square root of 2 over 2 for the x value. Again, I'm only looking at the x value because the equation is cosine. So remember, the first number there is always the cosine. So that's 5 pi over 4 and 7 pi over 4 for the angles. All right, so let's jot those down. So x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Now, it was easy for me to remember those without having to go back to the diagram because the second number there, 3 pi over 4, remember that's the second quadrant where the numerator is 1 less than the denominator. This 5 pi over 4, that was from the third quadrant. And remember, the pattern there is that the numerator is 1 more than the denominator. And then the fourth quadrant, 7 pi over 4, remember, it's 2 times 4 minus 1 would give me the numerator of 7. So in the fourth quadrant, the denominators are 2 times the denominator minus 1. Okay, so we have 4 solutions there. So again, the steps were to first add 1 to the other side, divide by 2, and then take the square root so you can isolate the trig function cosine x. So remember, you want to isolate the trig function. And then use whatever method that you are comfortable with to find those angles. If the unit circle is your best method, use the unit circle. If it's reference angles or other memorization techniques, use those. All right, example number 3. All right, how about something like sine squared of theta minus 1 equals 0? Let's do a little factoring. Okay, so remember how to factor something like this? So like when you have x squared minus 1, the factors are x minus 1 and x plus 1. So we can do the same thing with the sine squared, where it would be sine of theta minus 1, sine of theta plus 1 equals 0. And then where do we go from there? We take each factor, like sine of theta minus 1, bring it down, set it equal to 0. Same thing for the second factor, sine of theta plus 1, set it equal to 0. Oh, and also, again, we'll be solving this on 0 to 2 pi. Finite solutions for right now. All right, now you have 2 equations to solve. So the first one there, sine of theta minus 1, just add 1 to the other side. All right, let's get that solution for this first piece. So remember, in the unit circle, you want to find theta where that sine of theta, remember the sine is the y values. Find me where the y values are 1s. All right, so let's take a little trip to the unit circle. Here we go. So remember 1s, remember what I said about those? 1s and 0s are usually at the top, bottom, left, and right sides of the circle, not in the quadrants. So if you take a look at the top of the y-axis, like up here at pi over 2, and let me clear out this stuff here so it doesn't confuse anybody. You see that the y value is 1. Is there any other position where the y value is 1? The answer is no, right? Because over here at 180, whoops. I think I accidentally clicked on one of those ads, chewy.com, looks like for your pets. All right, so if I take a look at the 180, the coordinates here are -1 and 0. Well, that's a y value of 0, so that's no good. Over here we have 1 and 0. That 1 is an x value. So that's not what I'm looking for. That would be a cosine problem. The y value is 0, so that's no good. So right now I have one solution from there, and that's pi over 2. All right, and now the second equation, we're going to subtract 1 from that sine of theta, and it gives me sine equal to -1. So again, same idea here with the unit circle. Find theta, where the sine of theta, which is your y value, is -1. So let's take another trip back to the unit circle. And if we look at the bottom of the circle, we can see right here, these coordinates of 0 and -1. Right there, the y value is -1. So this angle, 3 pi over 2, is the solution to this piece. Okay, so there are your two solutions of pi over 2 and 3 pi over 2, or 90 degrees and 270 degrees. But again, we want radian angles. All right, how do I know I want radians? Well, the problem right here, when it says 0 to 2 pi, that means do it in radians. I know it's your favorite thing. All right, one more little example here. So let's say we have the cotangent of theta plus 1 in parentheses times by the cosecant of theta minus a half equals 0. All right, now what do you notice about this equation? Of course, we're going to solve it on 0 to 2 pi for finite answers. But you notice something? It's factored already. All right, so this is already factored, which means somebody already did a little bit of work for you. So now all you need to do now is separate the factors, cotangent of theta plus 1, set it to 0, and then take the cosecant of theta minus a half, set it equal to 0. And just like the last problem, you're going to solve each factor separately, like it is its own equation. If I can spit that word out, like it's its own equation. I do my best. All right, so now cotangent of theta, let's isolate that. So subtract 1 to the other side. Now, cotangent, don't forget, is x divided by y, okay? Maybe you don't like that. Maybe you'd rather have it as a tangent. Well, remember, this is the reciprocal of -1. What's the reciprocal of -1? Well, it's 1 over -1, which is -1. So cotangent and tangent are equal in this problem. They're both -1. So now what am I going to do with this? So now we want to find theta such that the tangent, which remember is sine divided by cosine, or y divided by x, will equal -1. Now this is almost the same thing as 1, so that means x and y have to be equal but opposite. Or equal but opposite. Like 3 divided by -3 is -1. So like 3 and -3 are equal and opposite. So now you got to find in the unit circle there where you have x and y values that are equal in number but opposite in sign. All right. So like for example, this point here that I'm circling, is this an acceptable location? The answer is no. They're equal, but they're same sign. So that's not good. That's same sign. No good. So how about we go over here? Those are equal and opposite signs. So that means when I divide them, I'll get -1. And that's what the tangent would be. So 3 pi over 4 is an angle. How about down here? Is that an acceptable location? The bottom left. The answer is no, because they are not opposite in sign, right? So when you divide that, that would give you +1. So that's no good. But then over here, in the fourth quadrant, just like where 3 pi over 4 is, we have opposites, and when you divide them, you'll get -1. So 7 pi over 4 is the other angle. So 3 pi over 4 and 7 pi over 4. So that's just the half of it. Now, the cosecant of theta. Let's add that half to the other side. And then the reciprocal, remember, is sine. So sine is the reciprocal of cosecant. So I'm going to write this side as sine. The other side is not a half. It's the reciprocal of that, which is 2. Now here, we want to recall something from yesterday about the range. So the range of sine is, remember, it's -1 to 1. So that means the sine can't equal 2. It can't equal 3 or 4. It can only equal numbers between -1 and 1. So therefore, there's no solution to the second half of the problem here. All right, so no solution in this section, since 2 is not in the interval. The interval from -1 to 1, that is, the range of sine. All right, so 2 is not a possible value of the sine function. This year, you're taking a little time there to get caught up, think about what's going on here, and make sure it's making sense. This way you can ask me questions later during the lab or whatever. All right, so what I would like to do for you now is one more example here before you go to the next part of the lab. In fact, from the lab, I'm going to do one problem. So I'm going to do problem 4C, which is going to be the next set of problems that you're going to do. So you're going to have 3 to do for me. So let's do 4C together. So that is solving the square root of 2 cosine squared of theta plus cosine theta equals 0. And note that the directions do say on 0 to 2 pi. All right, so now in this problem here, we're also going to factor. All right, but here the factoring is the easier type of factoring, which we call the greatest common factor, where we can factor out a common term, and that common term is cosine. So I'm going to factor out a cosine from this equation. And that's going to leave me with, inside, square root of 2 cosine theta plus 1. All right, so just double checking that. When I factor out a cosine from both terms, I'm doing the opposite of the distributive property. So here, cosine times cosine gives me cosine squared. Cosine times 1 gives me cosine. So the factoring looks good. All right, so we factored that. And now, like the other problems, separate the factors now and set them to 0. And now you got 2 pieces to solve separately. So the first piece, all right, the cosine of 0, so remember in the unit circle, all right? So we're going to find theta where the cosine, which remember is any x value, in this case, an x value of 0. And there are 2. So here we go, a trip back to the unit circle. All right, so where are the x's zeros? Well, remember again, zeros and ones are going to be at the top, left, bottom, and right of the graph. So let's start at the top. Do I have an x value of 0 there? Yes. So that means pi over 2 is a solution. And if I move it on down, if I can get this thing to move, here we go. There we go. If you look at the bottom there, there's another x value of 0. So 3 pi over 2 is the other solution. If I go to the right side, that's not going to work. Like here, a 1, that's not 0. So we don't want that. Ah, darn it. If I go to the left side, there's a 0 there, but it's not an x value. This x value here, that's no good because it's not 0. So we get pi over 2 and 3 pi over 2 as solutions so far. Now let's take a look at the other half. So now we have to solve this a little bit by isolating the cosine of theta by first subtracting 1. And then dividing the square root of 2. And then rationalizing, so I get negative radical 2 over 2. So you see what we're doing here is finding theta on the unit circle where the cosine, which is any x value, is negative square root of 2 over 2. Okay, so on the unit circle, those would be at, I'll let you look those up later, but I'll tell you right now they are 3 pi over 4 and 5 pi over 4. That would be in quadrants 2 and 3. You'll find those values where x is negative radical 2 over 2. So therefore, my solution set has 4 answers of pi over 2, 3 pi over 2, 3 pi over 4, 5 pi over 4. Remember, this is one equation, so there's one solution. Well, one solution set. There's 4 solutions, but they should be placed into a set because these are solutions to the whole equation. All right, not just the individual factors, but to the whole equation. So you don't want to make it look like there's 2 different sets of answers. It's really just all one big set of answers. So you group them together in the end, and then that will be your answer. Okay? So now I think we're at group work number 2. So we'll do this, and then we'll come back, and then we'll do the last part of our lecture. So group work number 2, you'll do for A, B, and D. All right, and why don't we make this 10 minutes? All right, because you don't have much to do with these, so just be careful with B especially because there's a square there. You're going to need a square root eventually. D is easy enough because D is factored for you already, so you don't have to do the factoring in D. It's done for you. Okay, so let me give you 10 minutes to do that. And then we'll come back for the final part of our lecture. Okay, so I have the room set up. I'll see you in 10 minutes. Continue. So I just hit record. And now let me share my screen with you again. Okay, so let's pick up here at review. So yesterday, when we were talking about graphs of trig functions, we were talking about their periods. And remember that the period is defined, well, for sine and cosine at least, right, as 2 pi divided by the b value. All right, that's going to be important for the last part of the lecture here with solving trig equations, because so far, right, so far, we've been solving equations where b is 1, which means period doesn't change, because 2 pi over 1 would be 2 pi. But what if the b value is something else, like 2 or 3? You know, that's going to change the solutions. That will change the solutions if the period changes. Okay? So if the period changes, we will end up with more solutions. All right, but also possibly we could end up with less solutions. It just depends on which way the period changes. So think of it like this. So let's say I'm on a circle, right? And let's say there's 2 points on the circle, let's call them A and B, that are solutions. So let's say the solutions are at A and B. So when your B value is 1, what that means is that if you go around the circle once, you will hit those solutions once. Okay? So when, I shouldn't have used B, I should have used something else. Darn it. Instead of this B here and that B there, I don't want to confuse it with the period. Let's use C. Okay, because we're already using B for the value going into the period. All right, so when B equals 1, the period is 2 pi, which means I will hit A and C only once because I go around the circle only once. Well, what if B is 2? Then the period becomes 2 pi over 2 is pi. And then what happens there actually, remember B is called the frequency. So in this case, I'm going to travel around the circle 2 times. Okay, I'll travel around the circle 2 times. All right, so I will go around the circle twice, which means what? Then I will hit A and C twice. So I hit A 2 times and I hit C 2 times. So what that means is, in this case, I end up with 4 solutions. If I go back to the first case when B is 1, I go around the circle once and I hit A and C only once. That means I get 2 solutions, which are just A and C, one at a time. But if I go around the circle twice, I hit A twice and I hit C twice. So think of it as like I have an A now and an A later. And I have a C now and a C later if I go around twice. Okay? So we need to keep that into consideration if we have a B value that isn't 1 when I'm solving the equations. Because then it's going to induce more solutions. All right, so let's do 2 examples here. All right, so let's say we wanted to solve the equation, the sine of 2 theta, so B is 2, equals a half on 0 to 2 pi. Okay, so now, all right, let's go through this problem. All right, so now the sine term is already isolated. All right, so this, we don't have to really solve the equation. We don't have to rearrange it. It's already isolated, the trig term, that is. So now, let's try to be a little verbal about this problem. In the interval, right, 0 to 2 pi, right? We could also say on the unit circle, right? Let's first try to figure out what angles we're going to be finding here, and then we'll figure out really what to do with them. All right, so remember, we find theta where, now remember, this is a sine function, so sine is any y value in the unit circle, where will equal a half. So that would be at theta equals pi over 6 and 5 pi over 6. I'll let you catch up there. Now that sounds nice and everything, but that's not the final answer. We're missing a couple of solutions from this. And the reason why we're missing some solutions is because we have a b value of 2. So remember, that's really going to double the number of solutions. All right, and also look at where the 2 is. It's with the angle theta. 2 times theta, 2 times the angle. So we're not multiplying the angles by 2. That's just indicating to us that we're going to have double the number of angles. Okay? So now what do we do with this? So that's the first step. Here's the second step. So now we have to talk about the period. So the period of y equals sine of 2 theta is, remember, it's 2 pi divided by 2 is pi. So what does that mean? All right, so that means in the graph or on the unit circle. So in the circle, you will go around twice. So you will have not 2 solutions, but 4 solutions. Because you're going around the circle twice, and those 2 values we just picked out, they're going to get hit twice. Okay, they get hit twice. So you can kind of think of it like that. So now, what are those solutions? So now to get the solutions, what we're going to do is we're going to use first the general solutions to find all missing solutions. And that's for the angle or actually not for, but using the angle to theta. All right, and that's because that's the angle that's given to me. So it's the sine of the angle to theta is what equals a half. Not the sine of theta equals a half, but the sine of 2 theta equals a half. So then what we're going to do is, so solution number 1, whoops. So solution number one, we'll say, all right, well, angle 2 theta will equal pi over 6 plus k times 2 pi. So remember, that's your general solution for a sine function. You have to add k times 2 pi. And then the second solution, I'm going to make room, will be 2 theta equals the other angle I found, 5 pi over 6 plus k times 2 pi. Now, we already have two of the solutions, and that's when k is 0. All right? So if we let k equal 0, we can get one of these missing solutions. All right? So remember that we already have, so far, let's make sure we make a little list here. So far, the solutions are pi over 6 and 5 pi over 6. So now by plugging in k equals 0, let's see if we can get another solution. So then we get oh, actually, I forgot one little step here. That's why I'm hesitating. I had a feeling I was forgetting something. Okay, I didn't solve for theta. So you have to divide both sides by 2 there, okay? So if you divide both sides by 2, you can easily see that here we get k times pi. Right? Because the 2 will cancel out after the plus sign. But then what about pi over 6? Pi over 6 divided by 2 is pi over 12. Okay? All right, now let k equal 0. So theta will equal pi over 12 plus 0 times pi. 0 times pi is 0. So we get pi over 12 plus 0 is pi over 12. So we're going to add that to the list. Because remember, it's really 1 pi over 12. So that's, that is between 0 and 2 pi. Because think of 1 over 12. 1 over 12 is between 0 and 2. So that's definitely a solution there. All right, in part 2 here, we're going to divide by 2 first to solve for theta. So we get 5 pi over 12 plus k times pi. So again, the 2 will cancel out at the 2 pi when I divide that by 2. And then when I divide this by 2, it's really going into the denominator. So it makes it 12 instead of 6. So in case you're wondering why that isn't 5 pi over 3, why is it 5 pi over 12? Real quick, 5 pi over 6 divided by 2 is what I'm doing. But what's the alternative to that? I can multiply it by the reciprocal, which is 1 over 2. And then multiplication, I just go straight across. 5 pi times 1 is 5 pi. 6 times 2 is 12, not 3. Okay? So in case you were wondering. Now down here, we can also let k equal 0. So that means our theta will be 5 pi over 12 plus 0 times pi is 5/12 of pi. Now again, think about this. Is this between 0 and 2 pi? Remember, just ignore the pi, don't forget, right? So 5/12 is between 0 and 2. So this is another solution between 0 and 2 pi. So I'm going to add that to my list, and there I go. There's my 4 solutions. So the first 2 were found on the unit circle. Okay. Oh, no, I'm sorry, that's wrong. These are not solutions, these two. So far, I only have two solutions. They go into the formula here. Sorry about that. So we have, let me clean this up. So far we have pi over 12 and 5 pi over 12. So what we want to do is note that pi over 6 and 5 pi over 6, those aren't solutions, all right? But they're used to find the solutions in the formulas that you see right here on the page, okay? So that means we need to get two more solutions. So let's pick another k value like 1. So then I'll get pi over 12 plus 1 times pi. And then down here, we'll get 5/12 pi plus 1 times pi. Now we got to add those fractions together. So we get pi over 12 plus, well, plus pi. But pi could be 12 pi over 12. So I have a common denominator, and that will add up to 13 pi over 12. And then down here, we'll have 5 pi over 12 plus 12 pi over 12. Remember, that's 1 pi, but I need a 12 so I can add these fractions. And then 5 plus 12 is 17 pi over 12. So my solutions are these four values. But notice the pi over 6 and the 5 pi over 6, they are not solutions, but they were needed to get these solutions, okay? So you plug them into the general form, but then they change when you divide by the 2 with the 2 theta. So that's why pi over 6 is not a solution. It gets divided by 2, and it became that pi over 12. Okay, so in case you're wondering what the heck happened to pi over 6 and 5 pi over 6, I moved too quick on that one. Now the other answers here, like 13 pi over 12, just think about 13 over 12. It's 1 point something. So that's between 0 and 2 pi. And then 17 pi over 12, just think of 17 over 12. That's also 1 point something, just divided on the calculator without the pi, all right, without the pi, just to see if they're between 0 and 2. So those are the solutions on 0 to 2 pi. All right, let's do one more, but I'll give you a minute there to finish writing and catch up. Okay, so our last problem here, let's solve the very similar equation. The cosine of 3 theta is equal to -1 on the interval from 0 to 2 pi. All right, so in this equation here, the trig term is isolated already. All right, so with the same idea as before, all right, our very first step is to find in the unit circle, right, where the cosine, which is your x values in the unit circle, where it equals -1. And that would be at, let's take a trip to the unit circle. Oh, there it is, right there. The one that we marked before that was not a solution. All right, so here you go. The x value is -1 at that angle of pi radians, or 180 degrees. But again, we're going to use radians, so pi would be the answer there. And there's no other values, actually, that will work. All right, so like over here on the right side, the x value is +1. So that's not a point that we want. So just the left side would be an acceptable place. So that would be at the angle pi. So now, what we're going to do, now pi is not a solution because that's a solution for cosine of theta, right? So now we have to bring down 3 theta. Set it equal to that pi plus, remember for the general solution, for cosine, it would be k times its period of 2 pi. And then theta would equal pi divided by 3 plus k times 2 pi divided by 3. So notice I'm solving that equation for theta by dividing by 3. So now one solution. There's actually, I think there's 3 solutions. Let's see. So let's start with a nice starting value for k of 0. That will make this problem simplify very easily. So we would get theta equals pi over 3 plus 0. Right? That whole second part becomes 0, and I get one solution right there of pi over 3. But now what we have to do is use some more values of k until there's no more possible solutions. So let's do that. So now let's try k equals 1. So now using this, theta equals pi over 3 plus, if k is 1, then that becomes 2 pi over 3, which is 3 pi over 3, which is pi. Well, that's a solution then, because it's between 0 and 2 pi, right? Because that's 1 pi. So 1's between 0 and 2. Let's keep going until we realize that the numbers are too big. So if we plug in 2 now, we get pi over 3 plus, now in the box, you would do 2 times 2 pi. So that would give us 4 pi over 3. Is 5 pi over 3. Now what's 5/3? Right? 5/3 is 1.67. Well, that's between 0 and 2. So this is a solution. Remember, the fractional value without the pi must be between 0 and 2. Let's see if there's a 4th solution. So let's try k equals 3. So again, I would go up to the box here and I would fill in 3 for k. So that would give me 3 times 2 pi is 6 pi. 6 pi over 3 is 7 pi over 3. Now, what's 7 over 3? 7 over 3 is 2.33. Ah, that's more than 2. That's more than 2. So this is not a solution. All right? It's not in the interval 0 to 2 pi. So that means this is where I stop. So therefore, my solutions are those 3 numbers there that I circled. All right? So therefore, the solutions are pi over 3, pi, 5 pi over 3. All right, so hopefully that made a little more sense there, because in the first problem, I almost messed up the problem there. All right. So again, you could keep going with other values of k, but you have to stop at a certain point. And the point that you stop at is when a number like this results, where the fraction, like 7/3 here, is bigger than 2. All right. So then that would not be a solution because it's not between 0 and 2 pi. Okay. All right, so this is the point where I'm going to stop. So this will be our official end of class right now. But if you want to stick around, we can work on number 5 in the lab. Also, I did post just about 20 minutes ago while we were in our other group work. I posted in the announcements the solutions to yesterday's lab. So you can check that out. I should have that graded by probably by noon tomorrow, so you can check your grades. I've graded a few of them already, but most of you won't have a grade for it yet from yesterday's lab. So again, it is the official end of class, so feel free to sign off if you want. Otherwise, stick around, and I'd be happy to answer any questions. So why don't we say we'll cut the time at 9 o'clock. So we'll stick around for 15 minutes, ask questions, work on the lab, and then at 9 I will cut the feed.